I welcome you all for today's session, Code Converters. So in the previous session, we discussed about binary to gray. Now we are going to discuss about gray to binary. So in the first session itself, we have discussed about what is code converter and types of code converter. So we also I have informed you that if we are able to convert, it is a vice versa path. If we are able to convert binary to gray, and if we understood how to convert binary to gray, then it is easy for us to convert gray to binary, since the same truth table we have to interchange. So for binary to gray, what was the step we discussed is, for binary to gray, we have to represent binary as B1, B2, B3, B4, and for gray G1, G2, G3, G4. For binary, B1 is equal to G1 and B2, G2 and G2 is equal to B1 XOR B2, and G3 is equal to B2 XOR B3, and G3 is equal to G3 XOR B4. So likewise we have converted binary to gray, and we have formed a truth table, and with the truth table we have plotted K-map, and we explained and derived, proved that B1 is equal to G1 is equal to B1 and G2 is equal to B1 XOR B2. Same likewise we used XOR function, right? So here now we are going to discuss about gray to binary. The gray to binary is nothing but vice versa of your binary to gray, right? So there our B1, B2, we had a function like G1 and B1 is equal to, and the adjacent, the next we have used the XOR function with your adjacent bits, right? So here we have to use the XOR function both with your binary as well as gray. Okay, how we can use it? Like if gray to binary, your inputs will be like your binary inputs will be in your gray side, and in your binary side how will you convert? So G1, G2, G3, G1, G2, G3, G4 is our gray inputs. We need to convert B1, B2, B3, B4. How will you convert? As usual, there won't be any change in the first bit. So G1 is equal to B1. G1 is equal to B1. There is no change in that. Next one, B2. How can we convert B from G2 to B2? See, we have an answer with us, that is our B1. B1 is nothing but your G1. Okay. This B1 and your G2, we have to XOR G1 with your B2, that is your G2. Understood? So in cross like we can say diagonally, your binary and gray should be XORed, so that you will get the next answer. Understood? So your B1 is equal to G1. B2 is your B1 XOR G2. B1 XOR G2. So next you will get an answer B1, B2. So next our B3 is this B2 XOR G3. So you will get B3. So what is your B4? Your B3 XOR G4 is your B4. So likewise we have to diagonally use the XOR function. So here you can see the difference between the truth table of binary to gray and gray to binary. In binary to gray, you had your binary code 8421 code as your inputs, and gray was your output. Here your gray, whatever you found in that binary to gray conversion, that will be just interchanged in your truth table. Like your binary terms will be your output and your gray terms will be your input. You no need to again evaluate each bit. So the same truth table you can just interchange here. If you interchange, you will get gray to binary. From the table binary to gray, you can get gray to binary. So this is the truth table of gray to binary. So in this truth table we can see first one is your input is gray and your output is your input is gray and output is binary. So with this truth table we can also prove by using K-map. We can plot and find the answers for B1, B2, B3, B4, and along with that we can draw the logic circuit. So this is all about our gray to binary. With this we complete our 2 code converters from binary to gray and gray to binary. Thank you.